Hello children, there is a name written on the blackboard, right triangle median theorem. If you start turning the pages of your textbook, nowhere in the textbook you will find a theorem by this name. If the name is not given to the theorem, then while writing the reason you have to write the full statement of the theorem. Okay? Or you can simply write by theorem. That is also acceptable. But it is very inconvincing. By theorem. Which theorem? We don't know. So it is better to give the name to the theorem. So from my side, I have given a name, right triangle median theorem. This is given to you on page number 38. Page 38 of your 9th standard textbook. Okay. So what the theorem says, in a right triangle, the length of the median drawn to the hypotenuse, median to the hypotenuse, is half of the hypotenuse. Okay. So this is the right triangle. This is the median which is drawn to the hypotenuse, and what we want to prove, that the length of this median is half of the hypotenuse. Okay. Now let us start the proof. First of all, let me recall the definition of median, which you have already studied in the lower classes. What do you mean by median? Median means the segment joining the vertex of the triangle with the midpoint of the opposite side. Vertex of the triangle with the midpoint of the opposite side. So as soon as we say that BD is the median, automatically D becomes the midpoint, and therefore I have given the identical marks on the two sides of point D. Okay. What we want to prove, that this median, the length of this median is half of the hypotenuse. So we have written that BD is the median, BD is half of AC, that is half of the hypotenuse. For that you have to make a construction. Take point E on the other side such that BD is equal to DE. We have written. Okay. Take point E such that BD is equal to DE and D lies between B and E. D lies between B and E, BD is equal to D. Join EC, draw segment EC or C. Now, if you consider these two triangles, triangle ADB and triangle CDE, this side is congruent to this side is congruent to this side, and these two are vertically opposite angles. Therefore, okay, these two are vertically opposite angles, and therefore the triangles are congruent by SAS test. We have written AD is equal to CD, this is given. ADB is equal to CDE, these two are vertically opposite angles. Okay. BD is equal to DE, BD is equal to DE by construction. We have done the construction. Therefore, these two triangles are congruent by SAS test. We have written that triangle ADB is congruent to CDE by SAS test. Now, if the triangles are congruent, obviously the sides and angles will overlap. So, which angle will overlap? Angle between 2 dash and blank is this angle. Angle between 2 dash and blank is this angle. So, these two angles will be congruent. We have written angle DAB is congruent to DCE. DAB is congruent to DCE. Okay, because these are the corresponding angles of congruent triangles. But what can you say about these two angles? These are alternate angles, and they are congruent. We have already proven. So if alternate angles are congruent, we know that the lines are parallel. So we have written, but these are alternate angles, therefore lines are parallel by alternate angles test. The test says that if alternate angles are congruent, then the lines are parallel. Now, as soon as you say that the two lines are parallel, then these two angles, they become interior angles, and we know that interior angles are supplementary when the lines are parallel. So if these lines are parallel, therefore I have written that these two angles are supplementary. Supplementary means their total is 180 degrees by interior angles test. Okay, interior angles theorem. But we have given that measure of angle ABC is equal to 90 degrees. It is already written. Okay. So in place of ABC, I am writing 90 degrees. Transfer it to the other side. 180 minus 90 is 90. So what you get is that measure of angle ECB is also 90 degrees. Either you write BCE or ECB, it is one and the same thing. So measure of this angle is 90 degrees. Okay. After getting that these two angles, this angle is a 90 degree angle, we will separate the two triangles. Which two triangles? ABC and ECB. Two triangles I am separating from the original figure. Okay? Right. So, when we have proven that these two triangles are congruent, there we have written a small conclusion which I had forgotten to write, so I have inserted. If these two triangles are congruent by SAS test, then this side will be congruent to this side because the triangles will overlap. This side will overlap with this one, this will overlap with this one. So obviously, third side will overlap with third side. That means the third pair is congruent. AB is congruent to C. We have written AB is congruent to C, called as corresponding sides of congruent triangle, CSC. So we have a conclusion that this side is congruent to this side. From where did you get this conclusion? From the congruence of the two triangles. Congruence of the two triangles. I have given number 1 to that equation. I am going to use that conclusion to prove triangle ABC and BCE. These two triangles congruent. See, what is the conclusion? AB is equal to CE, congruent to CE. AB, okay, this is congruent to CE. This is the right angle given and this is the right angle we have already proven. Okay, and this side is congruent to this side because it is a self-congruent side. BC is congruent to itself. What do you observe? Side angle side. Side angle side. So these two triangles are now congruent by SAS test. See, AB is congruent to C. AB is congruent to C from this equation 1. Okay. Then ABC is equal to ECB, both 90 degrees. ABC is equal to ECB, both 90 degrees. Okay. And this is congruent to this one. BC is congruent to BC because it is a self-congruent segment. And therefore, these two triangles are congruent to each other by SAS test. So now if the triangles are congruent means again overlapping triangles. This side will overlap with this one, this will overlap with this one. So third side will overlap with third side. That means AC will be congruent to BE. We have written AC is congruent to BE. Either you write BE, AC is congruent to EB. To maintain the 1-1 correspondence, I wrote it like that. Okay. After coming to this conclusion, important conclusion, I have written number 3 for it. Now, from the construction, I know that BD is half of B, क्योंकि इसी को तो double किए थे. So BD is half of BE, correct? But BE is equal to AC. So in place of BE, I can write AC. So in place of BE, I have written AC. And what do you get? BD is half of AC. BD is half of AC. That means the median to the hypotenuse is half of the hypotenuse. Proof is complete. Now this is a very, very long proof for the 9th standard students because there are lots of twists and turns. This is called an analytical geometry. Okay, but then the proof is not given in the textbook thoroughly. Only some points are given and you have to expand. So I have given you the full proof. But these types of proofs are expected from 10th standard students. And those children who can write analytical proofs, they only excel in mathematics. Okay? Simple proofs anybody can write, but the analytical proofs, इससे ये आता, उससे वो आता, फिर इसको इधर connect करके वो आता. This is called as analytical geometry. Okay? So I have given you the proof. The full proof is there on the board. You can copy it in your notebook. Thank you, children.